it tells you you've got a hyperbola with vertices blah blah and foci at blah blah. So when you know that you have a hyperbola, it's a matter of identifying which way is it going, left and right or up and down. Once you do that, then you know how to plot everything. So, or excuse me, not plot, we know how to count to find our A's and B's. So we start with just plotting it. 5, -4, and 5, 4. If those are vertices, where's your center? 5, 0. Right away, you know that your center's got to be at 5, 0 for your H and K. It's at the midpoint of those, okay? The center is going to be at the midpoint of either your vertices. The center is at the midpoint of your, hey, Trina! The center is going to be at the midpoint of your co-vertices, or the center would be at the midpoint of your foci. Means the same thing no matter what the conic is. The center is the midpoint of a focus and a directrix. Same deal. Foci, 5, -6, and 5, 6. So now you know that it's got to be an up-down hyperbola. If it's an up-down hyperbola, your y-squared stuff came first. And now it's a matter of counting your distances. Well, your A value is your distance from your center to the vertex. So A is 4. So A squared is 16. The distance from your center to the foci is your C value. So that means my C value in this case is 6, so C squared is 36. Well, a hyperbola has a subtraction between the two, which means the C squared is found by adding them together. I hope you've caught on to the relationship with that by now. So 16 plus what is 36? So B squared is 20. I now have enough info to write my answer. Here's where you're going to screw up. What's your H and K? 5 and 0. So K is 0. Y squared over 16. Yes. That's where you guys are going to screw up. The flip-flop. Yeah. Everybody make it. Okay. Yes, if I let you use your fancy calculators, you'll have the app button. If I don't let you use your fancy calculators, I'll give you the formulas. I'll put them out on a separate sheet of paper, and they will be just like what you see on the screens here. I do the exact same thing. All I do is I take, like you guys have seen me do this, where I'll just drag and drop it onto here. Yep. I've done this before. Yeah, and you're right. It's all you really do need. As long as you've got the pretty pictures, it's helpful. So basically, I just go through and I put all 4 of them on one piece of paper. I make it into a half sheet and just hand it to you. No. Yes, sir. Yes, sir. You can do y minus 0. Fine. Yeah, if you guys want to write y minus 0, that's fine. There's nothing wrong with that. Absolutely fine. Yeah. No, sorry. Yeah. No, it's the same thing where if you have something over 1, if you don't put it over 1, it's not a big deal. It doesn't have to be. It's adding on stuff that you don't need to add on, if that makes any sense. What else do you want to look at?
16.
I'm guessing we're really looking forward to seeing number 16.
Yeah, 16.
Parabola. Hey, I already did this problem. I could just go back and look at the backboard. Hey, look at this. On the back here, I have a vertex. I have a vertex located at 3, 1, a -3 and 1, right there, and a directrix at x equals -8, right there. Remember, your your vertex, that was called, always looks at a focus. A directrix will always be placed behind the vertex. So if the vertex is up, the directrix, do you mind fixing that? Thank you. I think it just snaps back on. The directrix would be below it. If it was pointing downward, the directrix would be above it. If it's going to the right, so the directrix on the left, and then this way on the last one. So since the directrix is behind it, that means it has to open up to the right. A right side opening parabola is a y-squared parabola. Now, you know it's going to be y squared, so it's going to be y minus k quantity squared equals 4p x minus h. Well, your hk is already given to you. It's at the center. So you're at our k value is 1, and then our x value is plus 3. This p value is the distance from the center to the focus. Well, if I went from my center, or my vertex in this case, to the directrix was the opposite of p. I went back 5, so it means I have to go forward 5. So my p value is 5. What's 4 times 5? The directrix is always the opposite of p. Okay? Your directrix is always the opposite of p, and since I went to the left, it was negative. Does that help on that? Thank you, sir. Okay. Anything else we got good? All right. Yay. Happy, happy. Last one, because I want to. We got stuff to look at here.
You already said we're ahead.
I know, but I still want to get ahead. Same deal. Come on, guys. Same deal. Start with your plot. If I have vertices that are vertical of one another, that tells you right away that it's a vertical ellipse. That means your a squared value is going to be underneath the y squared term. Okay, you know right away it's going to be up and down. So it'll be a x minus h over b squared, y minus k, 20 squared over a squared is that. So you have vertices at 2, -3, and 2 and 6. So what's -3 plus 6? What's half of that? 1.5. So my center is going to be at 2 and 1.5. Again, this is a scenario where throwing a decimal in there is a little bit easier than dealing with anything else. Not a big deal. So now we have to figure out our A and our B's and our C's. Well, the game's our foci. Our foci being at 2, 0 and 2, 3. So the distance from center to foci is C. That's 1.5. From center to vertex is our A value. And I believe that was 4.5. When you have an ellipse, it's a plus sign between the two fractions, which means when you're working with C squared, it's going to be a minus sign. So C squared, A squared minus B squared. So it's 1.5 is 4.5 squared, 1.5 squared. I believe you get 18 for B, B squared. And then A squared is 20.25. And it's just a matter of throwing it in the values then. Okay?
So with 2 and 1.5.
Yes, ma'am. Hold all your applause till the end, please. I seriously tried to be nice to you guys. Filter?
That's what my parents say.
Make sure your name's on that, send that up. Let's talk about the last little bit.
Almost done.
Yeah, I thought you could just put them all together.
Yeah, that
It's like the last bit of it. So this is the last bit of the 10-6 stuff where what we're gonna do is basically put it all together at once. Where you're gonna be given a conic equation in what kind of looks like the standard form of a quadratic, ax squared bx c and all that kind of stuff. This is technically what they call the standard form of a conic section, and there are ways of going about figuring out via discriminants and stuff to decide what kind of the conic shape it's going to be, but that's a pain to memorize, no reason to do it. Yes, ma'am? Yes, ma'am. This is how you put everything together. We'll talk about that more tomorrow, okay? So what we wind up having to do here is, like I showed you a little bit yesterday, we're going to start writing these things out in terms of figuring out which conic shape will this be, and once we figure that out, we're going to graph it, label all the parts, asymptotes if needed, and so on. So this is just starting at the very beginning and work through the whole thing. And this is where completing the square comes back into play. So when you have something like this, 4x squared minus 9y squared plus 32x minus 144y minus 148 is 0. What we're going to do is combine, or at least group together, your x's and your y's. Here's what it's going to look like. 4x squared, 32x, minus 9y squared, minus 144y is 548. We do that right away. Sending the constant to the right, grouping the x squareds, grouping the y squareds. And then when we do that, we're going to be able to set up to complete the square portion. Remember, the only rule that you had about completing the square was that your first term, your a value, had to be 1. So we wind up having to factor out coefficients. And here's where things can get, you're going to like this. It looks messy, but it's very procedural. It is, because it's the same thing every time, and you should not get really crummy numbers. You know, I mean, you might get a halvesy or something like that, but you're not going to get 144 over 6. Well, that's not bad. But whatever. Okay. So the first group, I got to take out the 4, and then I get x squared plus 8x plus blank, and I close it. That's what I'm setting it up to complete that square, because I want to turn that trinomial now into a perfect square. I do the same thing with the second part, taking out the negative 9. Y squared plus 16y plus blank. Just like we did before when we completed the square, we had to add something to both sides of the equation when you did that. Now I have to add something with the scalar put back into it. So if I took out a 4 here, well, we have our 548. It's going to be plus 4 times something minus 9 times something. Whatever I take out, I got to put back in. And it's really easily shown in this next step. Okay? It's very, very easily shown in the next step. Because when you complete the square, you take half of b, square it, and you add it to both sides. So if I do that, bring the 4 here, bless you. What's half of positive 8? Positive 4. What's positive 4 squared? 16. So at this point, I would just put 16 on both sides of the equation. But what's out in front of that? 4. So it's like you're distributing the 4 to here, so you got to put it to here as well. That's why you do it like that. Okay? I'll do that again with the 9. When I do the next part with the 9, I rewrite. With the negative 9 there. I take It's y, well, what's half of a positive 16? 8. So it's y plus 8. When I square a positive 8, what do you get? 64. So the 64 goes here and here. What's that? Oh. Okay. So now I've created two perfect squares on the left, and I got to figure out what all that junk on the right equals. It's 36. Thank you. So now I have to get that side equal to 1 by not subtracting 35. I divide everything by 36. Again, see how this is very procedural? Just follow the steps. 548 plus, what is that, 32, 64, and then that. So you get x plus 4 quantity squared over 9 minus y plus 8 quantity squared over 4 is 1. What shape is that? It's a hyperbola. And what direction is it going? You don't know, look at your calculator, it's going to tell you. It's going left and right. X is first, so it's going left and right.
Wait, so
No, then we go ahead and graph and label it. That's the easy part. And no, those numbers don't always just flip-flop each other, but you're going to see a lot. They try to give you numbers that have perfect squares. So you're going to see, guys, this is a really good question. When Haley was wondering, are those numbers always just going to flip-flop like 9s and 4s and 4s and 9s and stuff like that? Not necessarily, but they do try to make sure they give you stuff that's going to be perfect squares. 25, 36, 49, 64s, 16, 4s. So you see a lot of that. Okay. Sorry. Okay. Do you need me to go through and graph a hyperbola, or do we remember that when you do that, you have to find the following? A center, a vertex, a covertex, foci, and equation of the asymptotes. Okay. We can do one of them, that's fine. I just want to make sure you guys get practice at the equating and the square stuff. What's up?
I don't understand how you go from 4 quantity x plus 4 squared divided by 36 to x plus 4 squared.
What's 4 over 36? 1 9.
Oh,
9 over
now I
36 is
see
1
it.
4.
Alright.
So in this case, we had center at -4, -8. I have an a squared value of 9, a b squared value of 4, which means I have a c squared value of 13. A plus or minus 3, B is plus or minus 2, C is plus or minus 13. So we said it was left and right.
wait, 13.
Square root of 13. For C.
So I have vertices then at -1, -8, -7, -8. Yeah. Did I write? Oh, sorry, I didn't realize it. I was wondering why you guys kept saying that. I just forgot my symbol in. Co-vertices go up and down 2. So let's see, so we have -4, -6, -4, -10. Make the rectangle. foci is a little bit more than 3, so this was up 2, here's 3. Plug your asymptote and go. Oh, I just put that going the wrong direction, didn't I? Sorry about that. So it's this way. No, I didn't.
Probably why you didn't.
You're right. Thank you. Thank you. You guys see what I did? How I screwed that up?
Yeah.
I said that it was going to go left and right, but what didn't I draw in my picture? Oh, I didn't do a quick. I didn't draw that, so I just got ahead of myself. I should have done this, and I would have known right away.
13 doesn't have square. Was it close to? Was it between?
So we go this way.
It's like right in between.
Yeah. But remember how you write out the ordered pair for that, where the foci is going to be located? We're adding and subtracting to the x value here. So your foci, I would say, would be at -4 plus square root of 13, -6, -4 minus the square root of 13, -6. That's how you write those out. You can't get decimals. I don't care about decimals. You just write that as an exact answer and you're good to go. Okay. The asymptote part, your slope is relatively easy. You went up 2, we went over 3. So you have a positive 2/3 slope and a negative 2/3 slope. And then you always use the center as the ordered pair for your point slope form. Okay. Point slope form is H and K. Did you know that? Point slope form is H and K. Because when you have y minus y sub 1 is your slope, x minus x sub 1. Well, if I fill in the blanks here, it's y plus 8 is 2/3 x plus 4. I still got to bring this over to do that. So this was my k, and this is my h. So it's just slope x minus h plus k. Yeah, absolutely. It's quick. Since you're dealing with the center with it already has an h and k, if you want to do it that way, go for it. Or you want to write it out the long form, it means you'll get the same answer. Okay. You still got to get y all by itself and just substitute through. It's multiplying by a fraction it and a button in your calculator. Wah. Okay. Hyperbolas just take a while. That's it. But I'm not worried about this part because I know you guys can do this because you showed me you can do it and you really aren't screwing all that up. Unless you actually go the wrong direction. So just don't do that, you'll be fine. Yeah, like me. Don't be like me. What was the other one I wanted to do real quick? Oh wait, we did this one. Sorry. I think we set it up, we didn't finish it though. Alright, one more. One more and I'll give you a couple to work on. So, now we have the pass some papers back while I'm standing here while you're writing this down. Oh, you know why? I found it. It got stuck to. It got stuck to his. I didn't even notice until just now. You're right. It's right there. It just was stuck to his paper. So the whole thing was flipped over when I was going through stuff. I didn't even notice it. Sir. The complete the square part is what you guys use. It's another way of solving an equation for quadratics. When you're working with conics, you're right. No one's gonna say you have to do this, otherwise you're never gonna get a job. But the idea is, how does a focus work when you have a section like this? And why does it have to have a counterbalance behind it in order to take the image out itself? The real application of this, seriously, there's no other way around it. I mean, all those parabola problems, every single one of those is a physics problem. It's one of those things. That's where all this stuff occurs, is in physics.
Sorry, we can't all be as perfect as you.
I'm not far from it.
So again, as we start this one through, remember what we're going to work on. We're going to start by moving stuff around. You always want to move stuff around so you get your x squareds and your y squareds together. In this case here, if I start, I get negative 9x squared minus 36x plus 4y squared minus 16y is $1.64. Are we okay with that? All right. Now, after that, we have to start up the scenarios for working with completing the square. Remember, whenever you complete the square, the only rule that you have to abide by is the fact that the first term has to be what? 1. Okay. So since it's not equal to 1, when I have this 9x or negative 9x squared, I have to rewrite it as negative 9. I take that part out. I get x squared plus 4x plus blank. Take out the 4. I have y squared minus 4y plus blank. And then on the other side, same procedure. You put the 164, you put the 164, sorry. Then it'd be minus 9 times something plus 4 times something. It is extremely procedural. Okay. And then you go through the process of completing the square again. So we have a negative 9 here. What's half of positive 4? What's 2 squared? Put a 4 here and a 4 there. What's half of a negative 4? Square it, throw a 4 here and a 4 here. So now on the other side, you've got 144 minus 36 plus a 16. So it is 164 minus 20, otherwise known as 144. Ready to get all the 4s? Completing the square. I took half of b, I squared it, and I put it back. Half of negative 4, negative 2, I squared it, and I got a 4. Okay? That's where all that's coming from. So now on the other side, then it's going to equal 144. And then you careful. Yeah, there's 2 things you can do here. When you simplify this one out, you're going to get, you're right, it's going to be x plus 2 squared, and it's going to be over negative 36. Or like you were saying, if you flip them right away, yeah. That's 16, isn't it? No. Yes. Yes? Yes.
Yes.
it's not 16. It's 30.
They're flipped.
Yeah, they're flipped.
It's supposed to be like in
This is negative 16. This is 36. Thank you. I'm sorry. I got ahead of myself with all the. And that's what you're saying, Haley. Why are there always 4s and 9s? Well, it's why. So my final answer then, I have to flip-flop these. This is not an ellipse because of the plus sign. It's a hyperbola. That's a y squared because of the subtraction. Because you have the negative value never comes first. Remember how you said earlier to me that the a squared was always the larger? This is a good way of remembering why. Because the a squared is going to be first in this case. And isn't 36 bigger than negative 16? Same idea. So if you want to think of it how you were saying with the a value being positive, it's okay. It's not bad. What do you mean? Oh, yeah, remember, a negative fraction, this could have been negative 1/16 or 1 over negative 16. They mean the same. Yes. When you write fractions, guys, remember, fractions don't matter where you put the negative symbol. If it's minus, it could be negative 1 over 16, which is the same as 1 over negative 16, which is the same thing as negative 1 over 16. All three of those mean the same.
And the x value, can you drop the plus sign between x and the x value one?
I didn't mean to. I didn't mean to. I didn't mean to. Sorry. Okay. Yeah, the x plus 2 is still there. I just got ahead of myself. Yes, ma'am.
Are you going to make us find the equations and graph them on the test?
Yes, ma'am. But think about how many of those can I have you do?
3, and that can be our whole test. No, you should do 4, 1 of each, and then we turn that in, and that's our test.
Usually when I do with the conics test, it's usually 4 or 5 questions. If that.
More questions equal more answers you can get wrong.
No, I mean, it's where you can get,
Yeah,
yeah.
where you can get wrong. It's gonna be crazy.
Yes.
Get 5%.
Why it changed? Let me ask you this, Haley. Is negative 1/2 plus 3/4 the same as 3/4 minus 1/2?
Yeah.
That's why.
Every time, like every quiz, every test in that class.
That's why. You can flip flop because of addition. It's okay. That's the trick. That's about as nasty as these things are going to get. They'll make you forget to flip it. That's all. That's the only thing they'll make you do. The rest of it is pretty straightforward. Okay. And then obviously going through the rest. So this is going to be a hyperbola of y squared. Y squared and hyperbolas go which direction? Up and down. So don't be like a Murphy and forget to do this. Don't forget to do that. Just go. So we got time? We got time for 7 more. Let me help you set this one up real fast. This one, we started working through this one earlier. I want to make sure you guys see how this one sets up. Homework-wise, I believe I have you guys doing. I forgot what I don't think I wrote it down on the calendar. I forgot.
Like 5.
Yeah, it's 51, 2, 3, 4. Yeah, it's 53 to 61 on this same page. So. Yeah. And this is 53. So I want to help you guys start up. So it's the same page, 10, 6, 628, 629, whatever it is. And I want to help you guys set up what happens in number 53. When you set this one up, you're still going to set it up in the exact same way that we have before. We're still going to set it up to get to group together the x squareds and the y squareds with the x's and the y's and all that. But what's going to change is that you have to be very careful about your leading term coefficients. Excuse me.
You're kind of just something.
No, apparently not. It's most of the sleep I've gotten in a long time. The other night, well, I was sick, but the night before my dog kept waking up, driving me nuts.
Oh, wake up with bark or something?
My dog's getting old. She just doesn't like wind. She just barks. We're okay with that step, I'm assuming, right? Okay. Our next step then is to always make sure that our A values are 1. So we go ahead and factor out a 9 from the x's. I have an x squared minus 8x plus blank.
Part of the whole.
What do I factor out of those? Negative 1. That happens a lot. They will have just a negative x squared or a negative y squared. When you complete the square with that, you have to make sure you take the negative 1 out. Got it? Ready?
When you're adding like term and blank, so it's gonna be plus. Like,
Yes. Because no matter what, when you square either a positive or negative number, what are you going to get? So you'll have negative 119 plus 9 something minus 1 times something. And I'll let you guys finish that out. So yeah, it is those. I'll put it in there. Okay? Get the rest of these backwards. And they take a little bit of time just because of the way that you set them up.